Logarithmic differentiation. So when do we use that? Well, let's look at this function here. We have e to the minus 5x multiplied by x to the 5 multiplied by sine of x. So because we have three different functions multiplying together, the easiest way to calculate dy dx will be to apply the logarithms here. So what we'll do is we will apply on both sides, just like when we are transposing formula, and we will use the laws of logs. So on the left hand side we still continue with ln y. On the right hand side, the log of a product or two products will be the sum of the logs of those factors. So ln of e to the minus 5x plus ln of x to the 5 plus again ln of sine x. So let's see if we can simplify anything here or start applying the laws of logs. So ln y on the left hand side equals, now first law of logs, log of a power, so that exponent will multiply at the front, minus 5x ln of e. Same thing will happen with the second term. Power, exponent comes to the front, 5 ln x, plus, no simplifying to be done here, ln of sine x. Now, a bit more simplifying here, ln e equals 1, so we can just ignore that because it will blend in negative 5x times 1, negative 5x. So what are we going to do now? Differentiate each of these terms. So the derivative of course, with respect to x, so the derivative of ln y is, we know, 1 over y. But because we want this with respect to x, we'll multiply by dy dx. Just like as if we were differentiating a composite function. Y is the inner function that we don't know here. Now, negative 5x, derivative of that will be just negative 5. A linear function, we just get the coefficient at the front of x. Here, plus 5 ln x, derivative of ln x will be 1 over x. And now, derivative of another logarithm will be 1 over sine x. But also, that's a composite function here. Sine x is the inner function, ln is the outer function. So we have just differentiated now the outer function. Derivative of ln equals 1 over sine x. Now the derivative of sine is cosine. So it would be 1 over sine multiplied by cosine, which I have already combined in the same fraction. So let's keep going and see what happens in the next line. We could do some tidying up here. But maybe at the same time we do this tidying up, I'll tidy up the right-hand side by writing negative 5 plus 5 over x, multiplying 5 by 1 over x, plus cosine over sine. We could actually rewrite that as a simpler expression. Cosine over sine is the inverse of sine over cosine, which is 10. So this will be the cot of x. Now, dy dx here on the left hand side is what we want. So that means we need to try and remove that y from the left hand side. If it's dividing, we want the opposite or inverse operation, which will be multiplying. So all this expression here on the right hand side needs to be multiplied by y. So we are basically finished. All we could do here is again rewrite the final answer by saying that y is the original, very original expression we had here at the start. So we could, instead of y, write that e to the negative 5x, x to the 5 sine x, and that would multiply each of these terms here. So maybe I'll write that y at the front now. E to the minus 5x, x to the 5 sine x, multiplied by negative 5 plus 5 over x plus cot x. So that's not looking very simplified, so we might need to expand the brackets here. This is correct, but not as fully simplified as it could look. So let's see what we could do next. If we multiply out the whole expression here outside the brackets by negative 5, then by 5 over x, and then by cot, let's see what we get. So e to the negative 5x, x to the 5 sine x, first multiplies that negative 5. So I actually put the negative 5 at the front. Then that same expression multiplies 5 over x. So it will be e to the minus 5x, x to the 5 multiplied by sine x and multiplied by 5 over x, which was the second term inside the brackets. And then plus this whole lot again, e to the minus 5x, x to the 5 sine x multiplied by cot of x. So let's see what we can simplify here to make this a little bit shorter. The first term we won't simplify anything, so minus 5 e to the minus 5x, x to the 5 sine x stays the same. But in the second one, we can probably simplify the x to the 5 with that x on the bottom. So we would have, and maybe pull the 5 to the front, that 5 from the 5 over x. So 5 e to the minus 5x. Instead of x to the 5 now, we'll go down to x to the 4 sine x. And the last expression, because cot could actually be rewritten as cosine over sine, we actually could simplify that sine, those two signs there, and we would end up with e to the minus 5x, x to the 5 cosine x. We could keep going, but let's see what would be common here, at least to factorize a tiny bit. Perhaps the e to the minus 5x, that one seems to be the common factor, because and we could maybe bring the x to the 4 outside as well. So let's see how far we're going to go. So let's write e. So e to the minus 5x, open brackets. The first expression here will be reduced a little bit. So will be the second and the last one. We could easily factorize this again, bringing the x to the 4 outside. So it's just one more step for you to carry on.